In this video, we are going to talk about adding and subtracting rational expressions. So let's start with a few fairly simple examples, and these simple examples are going to involve situations where we have a common denominator. Okay, so for this first one, we have 10x minus 3y over 8x minus 5x minus 5, or 3x minus 5y over 8x as well. Okay, so in the case where we have a common denominator, just like in any other fraction, if we're adding two fractions that have a common denominator, all we really have to do is rewrite it where we add or subtract the numerators, whatever the operation calls for. So here we're subtracting these fractions, so we can just go ahead and write this as one single fraction. So we have 10x minus 3y minus 3x minus 5y. And this is all going to be over 8x. Okay, so now all we have to do is simplify the numerator. So we're going to have 10x minus 3y. And then if we distribute this negative sign, we'll get minus 3x. And we have minus a negative 5y, so that'll become plus 5y. Again, all over 8x. Okay? And now all we have to do is combine like terms, and we should be pretty much done. So we have 10x minus 3x. That's going to give us 7x. And we have negative 3y and 5y. That's going to give us plus 2y, all over 8x. And that's probably about as simple as we're going to make that one. You can't factor anything else out of the numerator. You can't cancel anything in the denominator. So we're going to say that that is as simple as this gets. Okay, let's try another one. Here we have 9a minus 6b over 2a minus a minus 11b over 2a. Okay, again, we know they have a common denominator, so we can go ahead and write this as one fraction with that same denominator. So we have 9a minus 6b minus a minus 11b. Okay, so again, just like last time, all we have to do is simplify the numerator. So we have 9a minus 6b minus a, and then minus a negative 11b is plus 11b. This is all over 2a. Okay, so once again, if we combine like terms, we should be done or close to done. If we have 9a minus a, that's going to give us 8a, and then negative 6b plus 11b, that's going to give us 5b. So plus 5b. This is all over 2a. And we can't factor anything out of the numerator that will allow us to simplify this anymore. So this is as simple as we're going to get this expression. Okay, now let's see what we can do here. So what you'll see here is that this looks a little more complicated, but they still have the same denominator. So let's go ahead and see what we can do. So we can rewrite this as one expression with the same denominator, z squared plus 2z minus 8. And now we have z squared minus 4z. And then we have plus 5z minus 6. Okay? If we combine like terms, we end up with z squared minus, we have minus 4z plus 5z, so that's plus z minus 6 over z squared plus 2z minus 8. Okay, and so now we need to factor each of these, okay? So we need to, let's start with the numerator. Okay, if we factor the numerator, we need to find two numbers that multiply together to give us negative 6 and add together to give us 1. That comes from the implied 1 in front of the z there. Okay, so two numbers that multiply together to give us negative 6 and add to give us 1. I'm thinking negative 2 and 3. Okay, if you multiply negative 2 times 3, we get negative 6, and negative 2 plus 3, that's going to give us 1. So we can do this as z minus 2 times z plus 3. Okay, let's look at the denominator now. We need to find two numbers that multiply together to give us negative 8 and add together to give us 2z. Add together to give us 2. Okay, So let's see here. I'm thinking 4 and -2, okay? 4 times -2 gives us -8, and 4 plus -2 gives us +2. So we have z plus 4 times z minus 2. Okay? And we should be able to cancel a little bit here. We have z minus 2 and z minus 2. So those will cancel. And we're left with z plus 3 over z plus 4. And that is as much as we're going to be able to simplify this. Okay, so what about a situation where they don't have a common denominator? So one option you always have when you have something like this, here we have 4a minus 7 over 4a plus 2a plus 1 over 6a. You could always take the denominator here and multiply the other term in your sum by that denominator over itself. And then same thing here, you could do 6a over 6a, and then that should give you a common denominator, but we don't actually have to do that here. We need to see what the least common denominator here is, okay? So they already have an a in common, so we can go ahead and ignore that. So an option, this is a totally valid option, would just be to multiply this one by 4, this right one here by 4 over 4, and this left one by 6 over 6. And that is always going to be a strategy that will end up working, although you'll have to do some more simplification later. But one thing you can notice is that if you can find something a little smaller, a little better, right? So if you were to multiply this right one here by 2 over 2 and this left one by 3 over 3, that would make sure that we get a common denominator of 12a. Okay, because if you multiply the left denominator by 3, you're going to get 4a times 3, which is 12a. And here we get 6a times 2, which is 12a. Okay, and again, this doesn't change the value of anything because all we're doing here is multiplying each of these terms here by 1. 3 over 3 is 1, 2 over 2 is 1. So nothing changes. We're just rewriting this expression. So this is going to be 3 times... Let's have the parentheses here. That way we can do easy multiplication, right? So if we multiply the numerator on the left term by 3, we'll get 12a minus 21. Okay, and then in the denominator, 3 times 4a gives us 12a. Okay, and then on the right side here, if we have 2a plus 1 times 2, that's going to give us 4a plus 2, and then again over 12a. And now we can go ahead and rewrite this as a single rational expression with a denominator of 12a. So now we're going to have 12a minus 21 plus 4a plus 2. And this is all over 12a. So now all we have to do is combine like terms. So 12a plus 4a, that's 16a. And then negative 21 plus 2 is going to give us negative 19, so minus 19. And this is all over 12a. And I think that's about as much as you can simplify this, okay? We can't factor anything out of the numerator that would allow us to cancel anything in denominators, so we are going to go ahead and say that's fully simplified. Okay, how about this one? Here we have 8c plus 3 over 3c minus 7c plus 2 over 9c. Okay, so what we can do here, what we can notice is that if we multiply the left term here, the 8c plus 3 over 3c, if we multiply that by 3 over 3, that will give us the exact same denominator as the 9c here. So if we do 3 over 3, this whole expression is going to become, so 3 times 8c plus 3, we're going to get 24c plus 9 over 3 times 3c is going to give us 9c minus 7c plus 2 over 9c. So now they have a common denominator, and we can write this as a single expression. So this is going to all be over 9c. So we have 24c plus 9 minus 7c plus 2. Okay, so we're going to get 29c plus 9 minus 7c. Okay, and then the minus will distribute to the 2, so we have minus 2. This is all going to be over 9c. Almost there. 29c minus 7c, that's going to give us 22c. And then 9 minus 2 gives us 7. So we have plus 7 over 9c. And that's as far as we're going to be able to simplify this one. Okay, so how about in a situation where we don't have something quite as obvious here? Well, we can still take the exact same approach that we had before, where we can multiply each term by the other term's denominator over itself. Okay, so anytime you see something like this and you're stuck, this is a really good time to do this. So that happens to be the method we want to use for this particular problem. But whenever you're in doubt, just go ahead and do the method I'm going to describe here. Okay. So to start with, if we want to find a common denominator here, what we can do is we can go ahead and multiply the left-hand term here by the right term's denominator over itself. So we can do x minus 2 over x minus 2. And we're noticing here, nothing really changes because we're just multiplying one of the terms by 1. Nothing really changes. Anytime you multiply something by 1, it's just itself, so we haven't changed anything. And the reason this is 1, x minus 2 over x minus 2. Anything divided by itself is just 1. Okay? And then we're going to multiply this one by 5x over 5x. Okay. So now let's rewrite this. So on the left term here, we have x minus 2 times 6. So we're going to have 6x minus 12. Okay, and then in the denominator, we're going to have x minus 2 times 5x. So we're going to get 5x squared minus 10x. Actually, let's go ahead and leave that unfactored at the moment. Let's just leave this alone. Oftentimes, it actually can be advantageous to not necessarily fully multiply those. Okay, and then we have in the numerator here we have 5 times 5x, which gives us 25x. The point being with that, you can certainly go ahead and FOIL those out if you'd like, or distribute that if you'd like. But you may have to do some factoring in the end. So let's just leave it undone for now. So we'll have x minus 2 times 5x. So now that we have a common denominator, we're going to get 6x minus 12 minus 25x all over x minus 2 times 5x. Okay? And 6x minus 25x is going to give us negative 19x minus 12. And this is going to be over x minus 2 times 5x. And I think that's probably about as simple as we're going to get this one. Okay? All right, how about this one here? Here we have 2 over x minus 5 plus 3 over x plus 4. So we need a common denominator. So what we're going to do, give ourselves some more space here, we're going to multiply the left term here by this denominator over itself. So we'll have x plus 4 over x plus 4. And we're going to multiply this term here by the left term's denominator over itself. So we'll have x minus 5 over x minus 5. Okay? So what we have here is, if we add some parentheses here, in the numerator, we're going to have x plus 4 times 2 plus 3 times x minus 5. And since now we have a common denominator of x plus 4 times x minus 5, we just have x plus 4 times x minus 5. We can simplify the numerator a little bit, and we'll get 2x plus 8 plus 3x minus 15. Okay, so, and this is all over x plus 4 times x minus 5. Okay, so 2x plus 3x, that's going to give us, it's going to give us 5x. Okay, and then we have 8 minus 15. That is going to give us minus 7. And this is over x plus 4 times x. minus 5. And that's probably about as simple as you're going to make that. Okay, let's look at another one here. This is where this can get a little more complicated. Okay, so let's have, here, let's look at this one. We have 3 over 2x squared minus 3x minus 27 minus 1 over 2x squared minus 13x plus 18. Okay, so I will say probably the best method to do here would be to go ahead and factor each of these. So let's go ahead and factor, we'll use different colors for this. Let's go ahead and factor 2x squared minus 3x minus 27. Okay, and so for this, we're going to use the AC method. So A, B, and C. So here we have A times C is going to, so we have 2 times negative 27. That's going to give us negative 54. Okay, and then B is equal to negative 3. So we need numbers that multiply together to give us negative 54 and add together to give us negative 3. Okay, so, all right, so let's think of factors of negative 54. All right, so if we start listing these here. Okay, obviously we have 1 and 54. Okay, we have plus or minus 1, plus or minus 54. Okay, let's see. And then we have 2, plus or minus 2, plus or minus 27. Okay, 54 is divisible by 3, so we have plus or minus 3, plus or minus, I need some more space here. There's a lot of factors. Okay, we have plus or minus 18. Okay, and then we have plus or minus 6, plus or minus 9. And I think, yep, that's probably going to be our answer right here. We can do 6 and negative 9. Okay, 6 and negative 9 are going to give us our answer here. So we can go ahead and rewrite this as 2x squared plus 6x minus 9x minus 27. And again, to see that, we want to have two numbers that multiply together to give us negative 54 and add together to give us negative 3. 6 times negative 9 gives us negative 54. And 6 plus negative 9 is going to give us negative 3. Okay, so then we can rewrite this as, if we have parentheses here, we have 2x squared plus 6x plus negative 9x minus 27. And here we can factor out a 2x, okay? And we'll have x plus 3, okay? And then on the right-hand side here, we can factor out a looks like a negative 9, and we'll get x plus 3. Okay, and if we undistribute, if we factor out an x plus 3, we get 2x minus 9 times x plus 3. Okay, so we have 2x minus 9 times x plus 3. Okay, so we're going to need that. Let's highlight that there. Okay, and now let's go ahead and do, we need a lot more space here. Okay, so now let's go ahead and factor 2x squared minus 13x plus 18. So now we're going to factor that. Factor 2x squared minus 13x plus 18. Okay, so let's go ahead and do the AC method again, where this is A, B, C. So A times C, 2 times 18, that's going to give us 36. And B is equal to negative 13. Okay, so let's see. what numbers will multiply together to give us 36 and add to give us negative 13? Okay, so probably going to be two negative numbers here, obviously, because you need them to be positive, and we have to have an addition to give us a negative 13. So thinking 9 and 4 should probably do it. Negative 9 and negative 4, right? So if you add negative 9 and negative 4, we should get negative 13, and negative 9 times negative 4 is going to give us a times c, which is 36. So we can go ahead and rewrite this one as 2x squared minus 9x minus 4x plus 18. Okay, and we can rewrite this using parentheses here. We have 2x squared minus 9x plus negative 4x plus 18. So for this left side here, we can go ahead and pull out an x, it looks like, and we'll have 2x minus 9. And we'll have, so we'll add here, and it looks like we can pull out a negative 2 here. So this will become minus 2 times 2x minus 9. And then we can undistribute that, and we'll get x minus 2 times 2x minus 9. Okay, so that was quite a bit of work just to get to the point where we can go ahead and rewrite this expression here, the initial expression. So we have in our numerator, we have 3 over 2x minus 9 times x plus 3. Okay, and we're subtracting 1 over what is now x minus 2 times 2x minus 9. Okay, cool. So now what we have to do is we have to find a least common denominator here. Okay, and what we'll notice is that these actually each have 2x minus 9 in common. So we don't actually have to include that in our cross multiplication here. It's not something we have to include. Okay, we only have to include the parts that they don't have in common. So you notice that this one has an x plus 3 and this one has an x minus 2. So let's start by cross multiplying here. We can just do x minus 2 over x minus 2. And then here we can do x plus 3 over x plus 3. Okay, and if we go ahead and multiply these out, we'll get, for the numerator on this side, we'll get x minus 2 times x minus 2 times 3 is going to give us 3x minus 6. Okay, and then we'll have x minus 2 times 2x minus 9 times x plus 3. And then over here, we have 1 times x plus 3. That's just going to give us minus x plus 3. And then again, we'll have x minus 2 times 2x minus 9 times x plus 3. Okay, and then we can just go ahead and combine these and create one rational expression. So we'll have 3x minus 6 minus x plus 3. And this is going to be all over x minus 2 times 2x minus 9 times x plus 3. Okay, so if we distribute that negative, we get 3x minus 6 minus x minus 3 all over x minus 2 times 2x minus 9 times x plus 3. And if we simplify this, it looks like we have 3x minus x is going to give us 2x, and negative 6 minus 3 is negative 9, so 2x minus 9 all over x minus 2 times 2x minus 9 times x plus 3. And you'll notice that the 2x minus 9 should cancel with this 2x minus 9, and we'll have a 1 in the numerator, and we'll have x minus 2 times x plus 3. And that would be how you'd simplify this one. Okay, cool. Well, let's go ahead and do one more example. That was a pretty lengthy example, but hopefully we'd all agree this wasn't too terrible. These aren't too bad. They're just a lot of steps, but it's all stuff we should be pretty familiar with here. It just takes a little bit to get it done, right? So it's pretty rewarding when you get one of these finished and you get the right answer. I will say that. So, okay, so now let's go ahead and do this one. This one actually doesn't look quite as bad here. So we should go ahead and see if we should just factor this left-hand side here. Okay, so let's start by factoring. Factor 3x squared minus 10x plus 7. Okay, so let's do the AC method. So we'll have A, B, C. So A times C gives us 7 times 3, which is 21. And B is equal to negative 10. So I think negative 7 and negative 3 would be the choice here. Negative 7 times negative 3 is 21. Negative 7 plus negative 3 is negative 10. So we can rewrite this as 3x squared minus 7x minus 3x plus 7. Okay. And then we're going to have, if we write this with parentheses, we'll get 3x squared minus 7x plus negative 3x plus 7. So here we can go ahead and remove looks like we can go ahead and remove an x. So we have x times, and that's going to give us x times 3x minus 7. And here we can remove a negative 1, so we'll get 3x minus 7. So we have x minus 1 times 3x minus 7. Okay. So there we go. We have x minus 1 times 3x minus 7, and now we can rewrite our expression. So we're going to end up with 2 over 3x squared. Oh, we don't want to do that. We want to do our factored version now, right? Just kind of blindly copying this here. So we have x minus 1 times 3x minus 7 plus 1 over x minus 1. Okay, and you'll notice all we're going to have to do here is multiply this, do our cross multiplication where we just multiply this term by 3x minus 7 over 3x minus 7, and that should give us a common denominator here, right? So we'll have 2 over x minus 1 times 3x minus 7. Okay, and then we'll have 1 times 3x minus 7 is just 3x minus 7. And we'll have x minus 1 times 3x minus 7. Okay. So if we go ahead and add across here, we'll have 2 and negative 7 is going to give us negative 5 plus 3x over x minus 1 times 3x minus 7. And I think that's probably about as far as we're going to get to go